In this lecture, we are going to see about sorting algorithm. Sorting algorithm is an algorithm that puts element of a list in certain order. The most used order are numerical order, either in ascending or descending order, and lexicographical order. We use sorting algorithm to optimize other algorithms like search and merge algorithms, which require a sorted input data. The data is mostly taken in an array form, which allows random access instead of a list wherein it allows sequential access. The two algorithms that we are going to see over here are bubble sort and quick sort. First, let us discuss about bubble sort. What happens in bubble sort is we'll compare each element with the neighbor towards its right. If they are out of an order, we'll exchange them. So this puts the largest element at the last. So the last element will be in the correct and final place. Once the last element has been put in a final place, we'll compare the next set of elements except the last element towards its right. If they are not in an order, we'll go for swapping. Similar way, if you go and complete with each pass, at the end of each pass, we'll have some element to be sorted in its correct position from the right. So we have to continue this till we don't find any swapping between the elements, wherein we'll end up with the sorted list. Now we see an algorithm related to our bubble sort. So we have n minus 1 passes. So for pass is equal to 1 to n minus 1, we initially assume that there is no exchange. So for the particular index for each position, we are going to find out till the n minus pass. So if an element at a particular position is greater than the next position element, we are going to exchange our element and we assign the exchange value as true. Else we are not going to exchange, we get incremented to 1, 2, 3, etc. So many passes we are going to increment the value of I and we are going to end up with the loop. So at last, when exchange is equal to false, we are going to stop the algorithm. So after the next pass, we are going to increment the pass value as 2, then we continue the same process till we get the element in a sorted list. So generally in each pass we have the element at the last position being sorted in its correct position. Let us consider an example for our bubble sort algorithm. Let's take 7 elements in an array of 10, 15, 3, 27, 9, 20 and 12. Now we have an array index starting at 10 will be 0, for 15 it is 1, for 3 it is 2, 27 it is 3, 9 it is 4, 5 it is 20, for 20 it is 5 and for 12 the index is 6. Now we have n elements in an array. So n value will be 7. So we have the first pass. So this pass will get executed for 0 to n minus pass. Totally 7 elements. So 6 passes it gets executed. So for in a for loop we are going to check out with 0 to n minus 1 pass, and we are checking out a condition if d of 0 is greater than d of 1, that is data of element at the 0th position is greater than data element at number 1. So we are checking whether 10 is greater than 15. It is false. So we are not going to have an interchange. We will write the array as such. We don't have any need to interchange. Now I gets incremented to 1. So it checks the index element at that position 1 is 15 greater than 3. Is 15 greater than 3? Yes, it is true. Hey, only we will interchange only if the condition is true. So we have interchange between 3 and 15. So the elements get swapped and the rest of the elements is retained as such. Now I gets incremented to 2. We check at the second position it is 15 greater than 27 at the third position. Is 15 greater than 27? It is false. So we are not going to rewrite or change the array. So we will write as such 15 greater than 27 as such. So we don't have any element to be changed. We retain it as such. Now we have I is equal to 3. So we are checking the third position. It is 27 greater than 9. Is 27 greater than 9? Yes, it is true. If it is true, we interchange the element. So we interchange the element between 27 and 9. So 9 and 27 gets interchanged and the rest of the position remains the same for other elements. Now we have I gets incremented to 4. So we check at the fourth position it is 27 greater than 20. The condition is true, hence we have a swap between 27 and 20. So the rest, only the 27 and 20 elements get interchanged. It gets swapped. Now we have I is equal to 5. So we have 27 greater than 12 checking. It is true. And since it is true, we have the swap condition. Last 8 elements between these two. This is now this 27 element is being sorted at the pass 1. Now we have come at the end of pass 1. So till this we have an sorter. The last element for every pass gets sorted. Now we will move on to pass 2. So in pass 2 again we start with 0. I is equal to 0. We are checking the element with 10 greater than 3. If it is true, we go for interchanging the elements. As it is true, so we interchange the elements between 10 and 3. The rest of the elements remain same. For this entire pass, this 27 will be in its current position. Now I gets incremented to 1. So 10 greater than 15. It checks. It is false. So we don't have any interchange. We write as such. I gets incremented to 2. So it checks whether 15 greater than 9. It is true. Hence we interchange the elements. We interchange between 9 and 15 over in the stage. The rest of the elements remains the same. Now I gets incremented to 3. Checks whether 15 is greater than 20. Is 15 greater than 20? False. So we are not going to have any interchange between the elements. It remains as such. Now it checks whether I is equal to 4. Is 20 greater than 12. Is 20 greater than 12? Yes, it is true. Hence we have an interchange between these two elements and we have 12 over here and 20 and 12 gets swapped. Now we have at 5 I is equal to 5. We have 20 greater than 27. The condition is true. Sorry, 20 greater than 27. The condition is false. So hence we have the element doesn't get interchanged in this pass. So we have come to the end of the pass. So till pass n minus 7. Sorry, n minus Pass is 2, so 7 minus 2, which is equal to 5. So fifth pass we stop it. So this is end of pass 2. In pass 3, we have the element at 3, 10, 9, 15, 12, 20 and 27. The last two elements are sorted in the pass 2 itself. So the index over here is for 3 it is 0, for 10 it is 1, for 9 it is 2, for 15 it is 3, for 12 it is 4, for 20 it is 5 and for 27 the index is 6. So for I is equal to 0, it checks whether 3 is greater than 10. If it is true, the exchange will take place. If it is false, there is no exchange. So we have the numbers being retained as such. So we don't have any change. When I is equal to 1, checks the index 1, element at index 1 is 10, greater than 9. It is true. Hence, we have an item interchanging between this 10 and 9. So 9 and 10 gets swapped. The rest of the elements retain its position. Now I gets incremented to 2, checks whether index element at 2. It is 10 greater than 15. It is false. So don't have a swap between these two elements. We have the numbers being retained as such. Now I gets incremented to 3, checks 15 is greater than 12, it is true. Hence we have a swap between the elements 15 and 12 and it gets interchanged. Now I gets incremented to 4, checks whether 15 is greater than 20, it is false. So we don't have any interchange. So we have the elements being retained as such. After third pass, the last three elements get sorted in its position. Now when we see this array, we have the list is being sorted. So in this problem, we have the elements get sorted in the third phase itself. But we have totally 1 to n minus 1 pass, that is 1 to 6 pass it takes. So the pass 4 to 6 will take place without any interchanges, without any swapping or exchanges taking place. So at last we have the sorted list as 3, 9, 10, 12, 15, 20 and 27. Next algorithm that we are going to see is quicksort. This algorithm is also known as partition exchange sort. Partition exchange, why do we say is, we first partition the array into two arrays, left and right array. So this quicksort algorithm takes divide and conquer approach. Suppose for example, if we have an array, it need to be sorted. If it is having only an element, it is done, and we are going to pick up any element in the array as the pivot element. An array element may be a first, last, middle, whatever the way we take a pivot element. So we partition the array into two groups, leaving the pivot element. So we call it as A1, the element less than P, and A2, the right array wherein the elements are greater than the pivot element. So we apply the quicksort recursively to the two subarrays A1 and A2 till we get a sorted array. So the trick lies in picking up a pivot element. So first we have to pick a pivot element. There are three strategies for picking a pivot element. First, in general, the method used is first element in an array will be taken as a pivot element. The second strategy is randomly we can choose our pivot element, and third strategy is median of 3. That is, we take the first, middle and the last element. Out of these 3 elements, we take the median of the 3 elements. So the algorithm for our quicksort is, the arguments it takes are an array, the lowest value, that is our starting value, and up, which is the end value. So we increment the low value, that is, we are going to compare with the first and the next element. So we have I index with low +1 and j as up. Then we are choosing an pivot element. So here we have taken this first element as our pivot element. We go for the loop wherein till the index are less than. So while a of I is less than pivot element, we increment the lower value I is equal to I plus 1. This continues till we get any element less than the pivot. And if it is greater than, we stop this loop and come out and go for the next higher loop, a of j, which is checked with the pivot element. It has to be greater. If it is greater, we increment the j index. Else we come out of this loop and checks whether this index I and j is less. If it is less, we are going to swap a of I and a of j. If it is not, we come out of this while loop and swap the pivot element with the j element. This is the procedure that we do it for one pass. So totally we will have n minus 1 passes. So here quicksort, after partitioning, this is a partitioning algorithm. So wherein we partition this into 2 subarrays, wherein the pivot element will be in its correct position. So we apply the quicksort recursively for the left subarray with this, and we apply the quicksort for the right subarray using this function call. Now we will see an example for this quicksort applying over this algorithm. Here we will see an example of quicksort by using our algorithm. Let us take the number elements 43, 72, 10, 23, 80, 1 and 75. So there are totally 7 elements wherein it will be stored in an array. So the array index will be 0 to n minus 1. Hence we will have the index as, for 43 as 0, for 72 it is 1, for 10 it is 2, 23 it is 3, 80 it is 4, 1, 5 and 75 the array index is 6. As per our algorithm, we have assigned I is equal to low plus 1. So the low is 0, so I will be now assigned to 1. So index I will point to the element number array index with 1. J is equal to up, means at the high end. So J will now point to 6. Our pivot element will be assigned to A of low. A of low is nothing but A of 0, because low is 0 initially. Hence our pivot element will be 43. So the pivot element is 43. So I will next it goes into the loop. It checks if A of I is less than the pivot element. So here, since I is equal to 1, A of 1 will be now 72. Our pivot is 40. So it checks 72 is less than 43. Less than or equal to 43. Condition is false. Hence it moves on to the next while loop, checks whether A of j is greater than or equal to pivot. So here j is nothing but 6. So it checks whether What is 6? 75. 75 is greater than or equal to 43. Condition is true. Now j gets decremented to 5. J minus 1. So it checks a of 5. A of 5 is now 1. 1 is greater than or equal to 43. This condition fails. So it moves on to the if condition. It checks whether I is less than j. I value is now 1 and j is 5. Is it less? Yes. If it is yes, it swaps a of 1 and a of 5. A of 1 is nothing but here 72 and a of 5 is 1. Hence, when we swap, it becomes a of 1 will be 72 and a of 5 will be, a of 1 is 1. After swapping, a of 5 will be 72. Hence, after this pass, we have the array as 43, 1, 10, 23, 80, 72 and 75. Now the loop continues. Now we have the new array as 43, 1, 10, 23, 80, 72, 75. Always when one pass is completed, the element in the last place will be in its correct position. It will be in a sorted place. Now we have the new array 43, 1, 10, 23, 80, 72 and 75. Now we have the pivot element being pointing to 43 again, and I is pointing to I, and j will point to 72 because j has been incremented to 5. Here the index will be, this is 0, this is 1, 2, 3, 4, 5 and 6. I is equal to 1. So a of 1 is nothing but less than or equal to 43. A of 1 is 1, less than or equal to 43. Condition is true. So I gets incremented to 2. A of 2 is nothing but, a of 2 is 10. 10 less than or equal to 43. It is true. So I gets incremented to 3. Now a of 3 is nothing but 23. Is 23 less than or equal to 43? True. Hence I will be incremented to 1, and hence we have a of 4 as 80. It checks 80 less than or equal to 43. The condition fails over here. So it moves on to the j loop. So j is now 5 over here. J is equal to 5. So a of j is nothing but 72. Check 72 greater than or equal to 43. Condition is true. So j gets decremented by 1. J is equal to 4. A of 4 is nothing but 80. So it checks 80 greater than or equal to 43. Condition is true. Hence j gets decremented to 3. Checks a of 3, which is nothing but 23. Is 23 greater than or equal to 43? Condition fails. Hence it checks I is less than j. So now the value of I is 4 and j is 3. The condition fails. When the condition fails, it swaps the pivot and A of j. Our pivot element is 43 and A of j is nothing but 23. So it swaps the places, it swaps between 43 and 23. Hence we have 23, 10, 1, 10, 43, 80, 72 and 75. Now we have find out this pivot element is in the correct position, because the numbers after this are and greater than 45 and the numbers below this are less than 43. So this is our left partition and this is our right partition. Now we have to check this 23. We will take the left array and 10. So now this becomes our P, this becomes I, and this will be our I, J. So now again the loop starts, since we are calling our quicksort recursively. So A of 1 is nothing but 1. So 1 less than or equal to 23. Is it true? It is true. Hence I gets incremented to 2. So 10 less than or equal to 23 condition is true. Only 3 elements are there, so it takes only till 2. So now it checks off with the J loop. So next while loop J is equal to 2. So it checks A of J is equal to greater than or equal to 23. It checks. The value of A of J is 10 greater than or equal to 23. Is it true? No, it is false. So it checks off with the if loop. If I is less than j, is 2 less than 2, false. Hence it swaps the pivot element and A of j. The pivot element over here is 23 and A of j is 10. So it swaps 10, 1 and 23. Now 23 is in the correct position. Now we have 10 and 1 left. So at last we will swap this 10 and 1. We have 1, 10, 23 non-sorted array of left sorted array. So hence our left partition is sorted. So now we have the right partition having the element 80, 72 and 75. P points to 80, I points to 72, J points to 75. That is, J is 2, I is 1 and P is 0th index. Now I is equal to 1 checks whether A of 1 is less than or equal to the pivot element 80. A of 1 is nothing but 72. So 72 less than or equal to 80, it is 2. So I gets incremented by 1, so I is equal to 2. So A of 2 is nothing but 75. 75 less than or equal to 80, it is true. So now the only 2 elements we have, so it moves on to the J loop, wherein J has the value as 2. Now checks what is A of 2. A of 2 is 75. The 75 checks with 80, the pivot element checks whether it is greater than or equal to 75 is greater than or equal to 80, it is false. So we have a check condition, we have to check with I and J. So I is 2 and J is 2, so whether 2 is less than 2, it is false. So hence we have a swap between the pivot element and A of J. Our pivot element is 80 and A of J is 75. So we have a swap between this 80 and 75, and hence we get as 75 72 and 80. Now 80 is in the correct position. Now we will have the swapping between the 75 and 72. 75 and 72. Now we have a swap. After swapping it, we are left with 72, 75 and 80. Now this right partition is sorted. Right partition is sorted. And hence our sorted array is 1, 10, 23, 43, 72 and 75. Last element will be 80. Thus we have implemented our quick sort using this example.